Hi everyone. In this video, I'm going to go through an application of synthetic division that we often don't get a chance to really dive into. And I thought it might be best to do it this way because it's pretty straightforward. Once you know how to do synthetic division, there's actually a little kind of result that's pretty interesting. So we call this the remainder theorem in terms of synthetic division. And so what that means is that if we do the process of synthetic division, that remainder that we normally put a box around at the end, where we circle or whatever your final number is, that's actually the remainder of when you evaluate the function. So that's actually the value of the function at that point. So for example, when we test for zeros and we get a 0 at the end, we know it is a 0 because that actually means when we plug in the number, we would have gotten 0 at the end. So I'm going to show you how this works in two different examples. So first, let's take this standard quadratic function. Let's do it pretty normally, g of 1. I would take 1 and I would substitute it in. So when I do this, I get 1 minus 4 plus 10, and so I get 7. Not really hard to evaluate, but if something is a little bit larger than a quadratic, a cubic, a quartic, a quintic, any degree higher than 2 might take a little bit of time for. So if I was to actually use 1 as my remainder here in synthetic division, and I follow my process, you can see that I actually get a 7 here. So notice how the 7's matched. This is actually the value of, g of 1. Okay, and now we could do another function here. So let's try it and see what happens. So let's use f. Now this is a cubic function, so 1. There's no x squared term, -5, -10, or -100, sorry. So bring down the 1, I get 5. Bring down the 5, I get 25. I get 20 times 100. And so actually we get a 0, which means f of 5 would be 0, which means 5 is a root. So we kind of knew this would be the process, but that's what it means. If I plug in 5, I get 0. And one more example with 2. So 1, 0, -5, -100. Bring down the 1, and just keep going. So the value of this cubic function at 2 is -102. All right, I hope that was helpful. There's some practice problems in Delta Math for you to try. See you in the next one.